Right, fun recording. All right, cool. Yeah, so to make the most of this workshop, I think it's best to focus on the high-level idea of how ReactJS works and trying to be able to read the code. Don't worry about the syntax. The goal of this workshop is definitely not to write working ReactJS code from scratch, but rather to really understand the key concepts of ReactJS. How do you run through the mental process of visualizing your front ends using ReactJS? And most importantly, be able to read existing code bases, because you would need to incorporate ideas from that into your own projects. Yeah. Okay, so the first key principle of React is that everything in React is a component. So in this example, we have the address form that can be broken down into different components, and each component has a particular function. So as a programmer, this is a nifty mental model to use, because it allows you to like decompose your app into a manner that's easy to reason about. And notice that like in any application, components needs to talk to each other, right? So for example, at the bottom, we have this green model, the validation result, and that appears because of data that came out from the address input. So a couple of key concepts here. First one is that everything is a component. Everything can be broken down into more components, and these components need to talk to each other. Yeah, so right off the bat, here's a quick hello world example in React. And this is how you go about implementing a component using JavaScript classes. And for classes, you have this critical function called render, which basically returns like what is to be rendered. And it's usually in HTML. So this is a simple example that just returns hello world, and it's wrapped in H1. So it's like big text, and this is pretty much how it appears here. And fun fact, these slides were actually built on top of ReactJS. So this is an actual React component, and the actual code is here. So like nifty stuff. Yep. So this example was how you go about implementing components using JavaScript classes. Another common pattern is to implement it as a function. So these are usually where you see your arrow functions come out. And in this case, we basically implement the same logic, but in the use of arrow functions. So functional components make sense if we want our components to be stateless, because like as the term functional suggests, there's no state. Yeah. So as mentioned previously, components can be made up of more components. So here's a quick example of how you go about composing React components. So in this case, what we have here is the main app component. And in the render function, we return this particular HTML syntax, and notice that there is this particular component called greeting. And that is what we call like a child component. And this component is implemented below here. Make sense? Right, next bit. So as mentioned previously, not only are components composed of more components, we also need the components to talk to each other, right? That's basically how you go about building front-end UIs. And there are two main ways of handling data. So the first one is props, and the second one is state. The TLDR is that props are things that can't be changed. You get it from your parents, and state are things that you can change, as the name would suggest. So let's take a look at props first. So here's an example of how you go about passing data with props. So in the previous example here, the greeting component prints out a message that's wrapped in H1 text. And in this case, the variable message exists like within the greeting class. So like suppose we want this message variable to exist in the app class. So like basically we want a way to sort of dynamically affect what's the greeting component is going to render. And that's when we would want to start passing props from the app, which is the parent, down to the greeting component, which is the child. So to do that, we basically lift the constant message up to the parent, and then we pass it down into greeting like so. So observe this syntax here. And this is what we call props. So the app component is passing the message variable, which encodes this particular string, welcome to React, as a greeting property down to the child component called greeting. And how greeting retrieves that property is with this.props syntax. So two main things here: you pass properties in this syntax, and then you recover the properties with the this.props syntax. Two main things here. Yeah, and for functional components, it's pretty much the same here. The only difference is that because it's an arrow function instead of a class, we'll just recover the props like so. So basically, it takes in the parameter called props, and then we recover it like this. Hopefully this makes sense. All right, so that's just props. So as we saw previously, like props are things that you get from parents, and you cannot really change it. So when it comes to adding interactivity into our applications, we need what is called state. So these are two examples of components that are interactive. So the first one is this like toggle button that toggles the state of this particular piece of text. And then there's this one that basically works as an increment counter. So let's take a look at how we go about like implementing these components. So for the first one, the now you see me toggle, the first bit here is that we need to set up the state. So that's done in the constructor, and it's done in this particular manner. So basically in the constructor, you have this .state equals to whatever state that you want to capture. So it's basically like a key value pairs, a set of key value pairs. And in this case, we decided to have this flag called is show, and it's set to true. So the default state is that the message will be visible as we saw earlier. And the next bit is that we need a way to modify the state. So an example that we set up here is the use of a button. And we add this on a click handler, which basically triggers this bit of code when it's clicked. So what it does is that it calls this React method called this.setState, and that is the function that mutates the state. So it is important that you use this particular method for updating the state. Otherwise, React will not be able to respond to state changes, and in fact, it'll probably throw an error. Yep. Okay, so basically, in this setState function, we are just essentially updating the state by toggling the value of isShow. Hopefully that makes sense. And then the last bit here is we decide whether we want the greeting component to appear with this ternary function. So this whole like ternary function bit is what we call conditional rendering, and it's like sort of like a key component of how you would go about writing ReactJS applications. Yeah, so another, sorry, so on top of just passing props down, you can also pass states as props. So in this example, so in the previous example, the conditional rendering exists in the app component, right? Suppose you want to push this bit of logic down into greeting. So to do that, we basically have to pass the isShow state down as a prop to the greeting component. And it's done like so. And pretty straightforward. This bit is what we saw earlier. And this is basically the prop for isShow. And we just basically shifted the ternary operator to here. So hopefully that makes sense. Yep. And just a quick recap of another interactive component. So this is the counter. Same thing here. Set up the state. And then set the onClick handler to update the state. And that's about it. And sometimes you also want like your components to look a bit nicer, right? So with that case, you start using what we call CSS. And there are usually many ways to style your components using CSS. So first one is using a CSS file that will take a bit of a look later. And another more straightforward hacky solution is to use inline CSS like here. So I guess like one thing you notice about these JS files is the mixing of HTML syntax and JS syntax. So whenever you want to like inject JS code, you'll do it by wrapping these curly braces. So for example here, you'd see that you have this HTML text, and then this bit is JavaScript, but it's wrapped around curly braces. Yeah. So now the next question that naturally arises is that can you pass props in the opposite direction? So previously you had always been passing props from parent down to child, so it only goes in one direction. Now can we go in the other direction? So the thing is that this is an intended feature of ReactJS, and no, you cannot. Like one of the key principles of ReactJS is unidirectional data flow. So you can only be passing props in one direction. That means here like a limitation, but the whole point of that is to sort of like allow you to better reason how your components work. Because if things can flow in both directions, it can get like super messy. So let's see an example where we need like the child to communicate information back up to the parent and how we might have to go about doing that. So in this case, we'll go back to the toggling example, and we now add a button component. So this is the previous implementation of the stateful app. Yeah. Okay. So previously, the button wasn't really a component per se, but it was like nested within the stateful app component. So now we want to move this up into its own component, and we do it like so. It's all going on here, but basically let's focus on this bit. So we now have the button as its own component. It has its own state, and then the same toggle show handler here. So when you click on this particular button, it updates its own internal state. So now the problem here is that we have this ternary operator here, and the predicate requires us to sort of have access of like this isShow variable, which was previously in the stateful app component, but has since been moved into the child button under here. So the question is like, can this parent app have access to this isShow? So things that you can't, right? Because the button is a child and you can't move things up. So the way around that is to basically lift the state up, right? So sort of like kind of like back to square one. So the isShow is back up into the stateful app, and instead, so the change we make for the button component is that we now pass this handler called toggle show. So basically what happens here is that when the button is clicked, it then executes this bit of code called toggle show, which in turn update the state of the stateful app. So the analogy for this is, as the parent, you would just throw a button with a string down to your child, and when the child needs to update anything, it presses the button, and then the parent responds to that. So that's like the mental model. Yep. So the button now takes in the on-click handler as a props, and that is what is triggered when you click on the button. Yep. So this bit sort of introduces the idea of being able to pass function as props to a child component. And what you learn a bit more about later is that you can basically pass anything down as props, even like components. Okay. All right, so another next bit is you can now compose React components with the use of the child property. So this is the previous example. Okay, so in the previous example, the button contained the text toggle show, right? So suppose you want to lift this back up. Like we just want the button to only handle sort of like the on-click bit. So we can actually change it like this. So this way we can actually sort of set the text of the button at the stateful app level. And then the button will just have as a property called children, and then it will slot the children in between this HTML text. So this introduces the whole idea of like passing components down as children. So hopefully this sort of like gives you a rough idea of how to use these tools to compose components together. Hold on. Looks like I'm not recording. Oh, I am. Okay, cool. All right. So in the previous example, we observed that we have to sort of like pass props down to children and so on and so forth, right? So basically, once you start building slightly more complicated projects, you notice that your tree gets pretty deep. And because of that, we run into this problem called prop drilling, where basically like properties have to go all the way down the chain and all the way back up, even for the most like standard of tasks, and that can be a bit of a pain in the ass to do. So a common solution around that is, it's not here, but if you were to Google the term prop drilling, you'll see like solutions to it, such as the use of React hooks or even Redux. But that's an advanced topic. But just be aware that as your projects become more complicated, like prop drilling will become an issue. Okay, so previously we showed the example of passing one particular children to be rendered. We can actually pass. So if you're building slightly more complicated stuff, instead of passing it as children, you can just pass it as a regular prop. So in this example here, we have sort of like, you can imagine it's like a forum when display a person's avatar next to a particular post. So we have first the user component, which takes in a user object, and it returns this particular bit of HTML. And notice that it is self-composed of like several more components, right? So you have the profile, the avatar, and the profile takes in as props user. So you come in here, and we need the user so that we can print the name here. And then for the children, it gets printed above. So you can imagine how this would look like is like you have an image here, and then the name goes at the bottom. And suppose you want to be a bit more explicit as to what this children is. So the way to do that is to say that, hey, the profile takes in two properties, user and avatar, and then we just render the avatar like so. So like that's the key change here. So instead of children, we are just basically doing a name for name replacement with avatar, so that we're more explicit with like what's going to be rendered here. And with that, you can take the idea even further by adding more components into the profile. So in this case, suppose on top of the avatar, we want to add Biblo, and we'll just do it like so. So we add additional property called Biblo, and we chuck it at the bottom here. And then this Biblo is implemented here like so. And the whole point of this is so that we can use this pattern called the slot pattern, which allows you to just quickly swap between components. So for example, in this case, suppose the avatar, which is the image of the user, was previously like stylized as like being round. And suppose I want to change that, I can immediately do a quick drop, like so. So that allows you to sort of easily exchange your child components dynamically. Yeah, so the key change here is that you can just basically change whatever that's here very quickly. And like previously, we also mentioned a bit of conditional rendering, right? So you can actually dynamically set what would display here as well. Right, so so this is where the prop drilling bit should have continued. So basically, one workaround around prop drilling is the use of context. So it sort of like reduces the number of hops you need to pass it around, and you can read more about it here. It's a relatively advanced topic, so we'll skip that. All right, so with that's pretty much covers like the basics of React. So there's a quick recap. The first point, everything in React is a component. Two is you need to pass data within components. So like there are two main ways of doing it, right? So the first one is props, which only goes in one direction, which is from parent to child. And in the event that it needs to go in the opposite direction, the fix is to use what we call state lifting. You move the state up, and then you pass down handlers to your children so that they can respond. And then the last bit is state, which is required if you want your components to be reactive. And as always, you always update the state with the setState function. Otherwise, you're probably going to break a lot of things. All right, so with that, let's just take a quick 5-minute break. And if you have any questions, just feel free to post in the chat. All right, cool. Let's just run through some of the questions that were asked. So the first one, oops. Okay, so the first question that was asked is, a bit confused about the solution for passing props from child to parent. So the general idea here is, okay, so like first and foremost, for React, right, data flow is unidirectional. That means it only goes in one direction, which as we mentioned earlier, is only from parents to child. So an example of where you might need direction. So an example where you might need data to flow in the opposite direction, we can consider maybe say this form here, right? So suppose like this, excuse me. So for example, you have the main app here, and then it has 3 children, right? So the address input, and then the validation result, right? So the validation result sort of like contains some information, right, that is dependent on its sort of sibling, which is in the address input. Yep. So with that, you can sort of see how data has to flow back up to the parent and back down. So basically, it has to go up from the address input and back down to the validation result. So this is one example where data might have to flow in the opposite direction. And the thing is that you cannot pass props in that particular manner because like the general idea is that it just makes data flow very confusing. So the fix to that is to basically lift the state up. So like whatever property that validation result depends on is now lifted back up into the parent level, which is the app here. And then we pass like handlers to both child so that they can respond. Hopefully that makes sense. The second one is if I want to create a button that renders an image on my existing page without changing what was there already, how would I do that? I'm not super sure what is meant by that though. But I'm assuming that it's probably some application of the slot pattern here. Yeah, so the whole point of all the various patterns that we described earlier is that it allows you to be very nimble in your design and you can like change things quickly. Okay, cool. So with that, like let's just move on to the second bit.
Raynold, he elaborated the question further in the chat. Yeah, you can take a look at it.
Oh, okay. Sorry, can you just like summarize it for me?
He's asking that if he wants to render an image when you click the button, right? Does he need to write another render in the onPress part? And no, you don't need to write a render. You can pass the component as he did earlier in the slides. Yeah.
So I guess like a comparable example would be something like this, right? So in this case, the greeting is conditionally rendered based on some state by the button, right? So in this case, I guess you can just swap this for your image. Hopefully that answers the question.
Does that answer the question, Huan Kang?
All right, cool, awesome. I think I just saw like more people jump in as in join the group. So for those, welcome. You kind of missed the first half. The second half is here doing a quick code dive to a working React application, and most importantly, seeing like how you go about like structuring such a relatively large project, and how would you sort of like interact with a backend database, which is pretty much like the requirement for a lot of projects anyway. Yeah, so you can see like working demo here. It's based off this React tutorial. So like as a follow-up, you can check out the tutorial and sort of see like a bit of the source material. This. Yep, and you can actually dig through the source code along with the presentation with this link here. Yep. Cool. So like just a quick recap on some of the requirements for Orbital. So for this Q&A application, it almost meets the criteria for full stack, right? So basically we have a web app with a database backend. We'll dive a bit more there later. There's like a very simple set of features. You can add questions, you can add answers, this sort of thing. It doesn't have testing, so that's something you guys have to sort of add on yourself, and it's also lacking documentation. Cool. So just a quick dive into what full stack development entails. You basically have two main components, right? So the front end, which is basically the web app that your users gonna interact with, and the back end, which is what your front end would interact with. So that's where you get your data from. So the focus of this workshop is really on the front end bit. So we'll just quickly abstract away what happens in the back end. So basically there are sort of like two main bits to it. One is the database, which stores your data, and the next one is like the web app. So like common examples for both are listed here, and like just check out more if you're interested. Yep. So let me just do a quick demo of the Q&A app. So basically what happens here is that you can add your own questions. And okay, I see other people also like posted stuff here. And so basically there are questions and then there are answers, right? So there is an answer here and so on, answered like so. So that's sort of like how the application looks like. And that is supported with a set of backend APIs. So yeah, basically four in this case. So the first one is get, which retrieves all the questions, get ID to get a specific question. So that would be for this example here, because we want to get the details for a particular question. And then the next two bits are post calls, which allow us to first inject a new question, and second is to add an answer to a question. So we won't go into details as to how this is implemented, but just note that like these are the APIs that our front-end app has to sort of like call. Yeah. So actually you can run these commands to see what you get. So if I run this here, so notice that this pretty much matches up with what we had here, right? Yeah, so basically you can think of our React app as getting all this information from the server and then processing it in a meaningful manner. So that's for the get, and then for a specific response. So for example, if I want to get the question of ID 1, I'll just add this /1 at the back, and then it returns data in this following shape. So that's that. So now if you want to insert a new question, we have to do a what's called a post request. So this is an example for doing this. If you run this here, let me just add more $signs because I think someone already ran this. And then I refresh the page. Yeah, you see that here. Yep, and posting an answer to the question works in a similar fashion. Yeah, all right. So this is basically the endpoints that our front-end application would have to call. So usually when you want to start a new React project, you'll just call these. You just run these commands in your terminal, and it just basically sets up the boilerplate code for you. And to just check that everything's working, you then call npm start. And when that happens, you usually get this bit. And then from there, we can sort of like start on the actual coding. But in this workshop, we just do a quick code dive, see how everything works. So in this application, because there's like quite a fair bit of navigation going on, we have to use additional libraries. So the first one, the first bit will be what we call a router. And it basically allows for seamless navigation. So like if you remember like internet in the good old days, like every link sort of causes a page refresh because you're loading a whole new page, right? So these routers sort of like allow for seamless navigation. So it sort of like allows you to do like the same page navigation without having to reload the whole page. And it also updates the history as well. So you can actually press like forward and back to actually see like what were the last pages you're at. Yeah. So we'll just do a quick touch and go of how the router works a bit later, and you want to learn more about its rich feature set, just check out the link here. Yeah. So okay, so next bit, we're going a bit fast and dirty, but maybe I'll just quickly give a quick rundown of the structure of the app. So basically, when you create a new React project with the npm create React app, this is more or less how the structure looks like, right? So you would have public, which sort of contains the files that would actually be served on the web browser. So we can just ignore that for now. So the one that's most important to us is the src folder, the source code folder. So it contains a bunch of stuff. So the first tool that will always be generated is the app.js and then the index.js. So index.js is like sort of like the main entry point, and then app.js is where you define your root component. And then there'll be a bunch of other components that we'll use. Yeah, so a bunch of other components that we use, and for now we just chuck them into their own separate folders. So hopefully that gives you a high-level view of how this project was structured. Right. So we first start off with the app.js, which I mentioned earlier is the root component. So it's like the mother component, if you want to put it that way. And so the first step is to add the router support. So the TLDR for that is you just wrap your app around browser routes, like so. Yeah, this is the TLDR bit here. It's this boilerplate code to get everything working. And then to sort of see how everything sort of like connects together, if you look at the index.js and the index file, to see how everything combines together, notice that the React DOM is going to render this particular bit, and then it's going to inject it in an an element by the ID root. And basically, this is where our React app will be rendered. So hopefully that sort of like closes the loop in how you sort of like get your React app up and running. Awesome. Okay, so now let's take a look at the interface of the Q&A app. And immediately we can like decompose it into its individual components. So you have the header on top, you have this big area with all the question cards. Let's just wrap that around with a container component called questions, and inside we'll have two types of questions, right? So we have a new question card for posting a new question and question cards for existing questions. So hopefully that bit makes sense. And now let's look into implementing the header. Oops, sorry, and then this is like the form for creating the question. So these are basically all the visual bits. So for a navigation bar, this is pretty much how you go about doing it. So we want the navigation bar to be clickable. So for that to happen, we just need to add the link text here. And there's this tool, which basically tells us where this link would direct us to. And here is this /, which means like the root page, so to speak. And then we export it like so. It's a common pattern. And then to add it in, we just slot it in like so. So we just import it, and then we just add the component here. Yep. So if we were to immediately do that and check the state of the app, notice that this is like really ugly bar here. And that is because there isn't any margin set. So it looks pretty crappy, right? So the common fix for that is to basically dig into your developer tools and manually play your values until it works. So we can like just quickly demo that here. Okay, so this is the original fix. I'm going to pretend that it existed. Okay, so if I refresh, you'll see that like it looks pretty bad, right? I'll give it a moment to rebuild. Yeah, so you see it looks pretty bad, right? So usually what I do is that you'll go into Chrome Tools, inspect the element, and then you'll just try to like scroll your way down, find the element. So in this case, we noticed previously that it was wrapped around in even bigger container, right? So we find that. So it'll be this one. So if you go on the computer, you'd see sort of like some additional margins and what have you. So let's just add this bit in. And we see that fixes the problem, right? So now that we know that margin 100 makes sense, we just add it into our CSS file. Yeah, so like this isn't meant to be a HTML CSS course, but hopefully you guys can see like how this influences the way in which these elements are presented. Okay, cool. So the TLDR here is use your Chrome developer tools actively to like fix all these annoying issues. Yep. Cool. So I should slow down a bit. So the previous mini exercise was just basically how you go about using your Chrome developer tools to fix like small like CSS issues. So the way to invoke it is to just right click and click inspect element. And then you can just like further around with this interface here. And then you can sort of set values for things like padding, border, etc., with this menu here, and you can even edit the properties here as well. Yeah. So hopefully that helps. Right. So the next bit would be question cards. So here is the part where we need to think about making the actual API calls, right? Because all the data in these cards were retrieved from making the API calls. So let's first think about how we'll go about making these calls. And for ReactJS, a very popular library is the AX, like I'm not gonna pronounce this, like this promise-based HTTP client. So for those that are familiar with Python, it's like the equivalent of the requests library. So it just helps you make HTTP requests quick and easy. So let's look at the questions.js file, which implements all of the question cards. So let's see how we would first go about making the API call. So first is we have this new question card that's implemented like so. We have the links here that basically tell us that, hey, when you click on the card, you go to this particular path. So this is the router link. So this is the one for the question card. So in this case, we implement it as a functional component because it's not really stateful, right? So it takes in as props a question object. And then it itself contains all of these fields, which is pretty much the response that we get back by making the API call. So let's see how we get this data from the backend. So the way to do that is to do a get call like so, and then we recover the data with the attribute.data. And notice that we have to do it in this funny component did mount function. And that seems a bit confusing at first, but the main reason is just part of like the life cycle of React components. It's a bit of an advanced topic, but the TLDR is that components in React have a particular lifestyle from where they are created to where they are being actually mounted, which is like being displayed, and when they are unmounted, basically being removed. And they are like basically key parts in the life cycle that you can have hooks to run code when these things happen. And basically, if you're making API calls which recover data that the component relies on, you just put it in the component did mount call. It's a lot taken, but like the TLDR is that if you're calling an API, chances are you should be doing it in the component did mount. Yep, so like here. Yep, so in this case, we make the get call, and then we set the state like so. So basically, in the component did mount, we'll be doing primarily two things: making the API calls that you need, and then updating the state. Right. So the next bit is, so if you saw previously, we're calling this like variable in block called like hostname, right? So where does this come from? So in this case, we just chuck it into this folder called constants.js, and then we set it to be the URL that we want to hit. So if you're developing locally, usually you would have your own backend in localhost, and then you would set it like so, localhost on whatever pod you're running. But in our case, because we are deploying it live, it needs to hit a live URL. So we set it like so. So this bit just allows you to quickly toggle between testing and actual production. Right, so now let's look into how you would actually render cards. So notice that we have like a string of cards that have to render, right? So with that, we have to do a bit of magic here. So the first bit is the new question card. Hopefully this bit makes sense. We're just rendering it like this. And then the next bit is we add this sort of conditional rendering where if the states of the questions, so if the questions are null, which is the initial state, it means that we haven't gotten the questions yet from the API call. As such, we just tell the user that, hey, we're loading, give us some time. And in the event that it's no longer null, you'll then go about rendering it. And that's done with the map function. So this bit is a pretty useful pattern for like rendering, say, lists or like multiple duplicate components. All right, so let's see how we go about injecting the new component bit in. And it's just like this, pretty straightforward. All right, so now let's just circle back to the React router, which basically handles the updating of the URL when you click on things, and it updates the view like so. So like as mentioned previously, you can just do all these cool things like, oh, this is an example. So like when I click on various links, it updates the URL like this, and notice that it doesn't really do a full refresh. So this bit is very different from like me actually refreshing. So that's like the key end user experience difference here. So previously, before routing, everything was implemented like this, right? You have your navigation bar and then your questions. So for us to support routing, we need to wrap it around like so. So basically, we now have to wrap the component in a route component. Okay, it's super confusing, but basically the pattern here is anything that is going to be captured by a route has to be wrapped in a route component. Hopefully that makes sense. And then the final bit is that you have to export the component with the with router. So basically, each router component has the following properties. So the first bit is like the path, which is what you want to update the address bar with. And in the event that you want to pass parameters into the path, you'll use these colon followed by the variable name here like so. So in this case, when I click on the question, so basically when I render this question component, it's triggered by accessing a URL of this particular path. And then this question ID will be passed as a property to the question component. So it's a bit confusing because like there's a lot of overloading of like questions and question, right? So questions are basically this whole bit. Question is without the S is basically this bit. Yeah, so basically this like mother component app defines all of the routes, like AKA web pages, if you will, and what you would pass into each web page, which is captured by a route component, the path, and then the component that it will be rendering. Okay, so let's just bear in mind this question ID a bit later. We'll see it pop up in a short while. Okay, so this is the question component, which is the this particular page. So let's see how it works. So the first bit is we need to make a GET request, right? So we'll make a GET request with the question ID to retrieve the data. And this happens in the refresh question function, which is in turn called in the component mount. So remember previously that we mentioned that anything that involves calling an API should be done here. So we're doing it again here. And this bit, this fancy bit here, is what the React router down passes to us for every route that's rendered. So notice that we, So notice that we recover the question ID from the params, which was taken from the match object here. A lot of it seems very arbitrary, but like it's just the way the API is. All right, cool. Yeah, so once we have the question retrieved from the API, we'll then go about rendering it. So like these are basically all the different properties of the question. You have the title, the description, and then the interesting bit here is this form, which is called submit answer. So sorry, this bit renders the answers and it uses the same map function that we saw earlier for question cards. And now let's take a look at the form for submitting answers, which is basically this bit here. All right, cool. Yep, so this is how the submit answer.js file looks like. Let's dive into the render function. So this form has a lot of L components, right? You have the answer here, you have this field text here, you have the button here. So one common pattern for returning multiple elements is to wrap them around a fragment. So it's just a pattern for returning multiple elements. You could just wrap it in a div as well. It's just a matter of personal preference. And then this is the text box. So you can think of this as like boilerplate code for implementing any like text-based form. You always need this. So what happens here is that this bit is your typical HTML input text element. This bit here is the onChange handler. So what happens here is that whenever you type text into the box, it triggers this onChange handler and it basically updates the value. Oops. Yeah. So yeah, the update answer is here. So notice that it's just setting the state of answer to value. And then this answer is reflected here in the value of the text box. Seems a bit contrived, but this is the common pattern for like implementing text boxes for forms. Okay. Right, so now the next bit is like what happens when we click this submit button. Right, so when we click the submit button, it will make a post request, right? So this is where we'll call the post answer path, right? So let's see how that happens. So for the submit.js, right, the onClick would trigger this function called this.submit, right? And this .submit is implemented here, and it calls props.submit answer. So this is like back to where we were previously, right? We're passing data back up to the parent. So this submit answer is basically the handler that's given to us by our parent, and it's basically implemented here. So what we do is that we call this function called submit answer. We pass in as the parameter as the answer they were submitting, and then the parent would recover the answer and make the post request, like so. Okay, so this is the submit answer JS, and this is the question .js. So once we submit the answer, we call this .refresh question. And once again, because the refresh question calls the set state React function, if there is a change in the question state, it is reflected in the UI. All right, cool. So that's sort of like a quick overview of a full stack front-end application. I know it's a lot to take in. If you have any questions, feel free to ask in the chat. So we have a bit of time left. So let's try to add some new features to our application. Oh, sorry, someone coming in. So let's add some features. So let's add like a voting system similar to your similar to your Reddit upvote and downvote system. And let's sort the cards by number of votes in descending order. So a working demo would be here. It's gonna take a while because it's Heroku. Yeah. Oops. Yeah. So we'll start off with the code here in the sandbox. Yeah. So in this case, because we are now adding votes, right? So we'll be using a slightly different backend endpoint. Using a slightly different backend endpoint. So yeah, okay. So this is the starting code for this mini assignment. So notice that when I submit a question, there are now these up and down vote buttons, and then this is like to-do text in the middle. So this would contain the number of votes. This would trigger an upvote. This should trigger a downvote. And that's pretty much about it. So to give you a working example, so this is the actual live demo. So there's a bunch of stuff here. So let's say I upload this. So upvote. Then of course this also includes like funny edge cases, right? Like you can't downvote this to negative infinity in this case. Okay, so so this is the upvote downvote bit, and then notice that when I click refresh, it's now sorted in decreasing order of votes. Yep. So the so if you look at the endpoint here, so this one hits a slightly different endpoint because we now have to add like the votes attribute, right? So if you look at constant.js, we're hitting this particular endpoint. So notice that the return includes this field called votes. Yep. And it supports okay, so like there are actually two backend paths for upvoting and downvoting. I'll add that bit in the chat later. But basically, just know that you're hitting a slightly different backend because of the voting feature. Yeah. So you can work on it online with Code Sandbox. So you don't have to like install new things and like install npm, that sort of mumbo jumbo. And a quick hint is that to implement the upvote downvote feature, you only really need to change this one file. And basically there is like almost a working solution here. Because basically what you're doing here is that you are clicking on a button that triggers a API call, and then you need to update the state of the card based on that. So this is basically the pattern that you sort of need to implement. Yep. So when you guys are ready, you can start working on it. And if you have any questions, just reach out in the chat. Yeah. So if that's pretty much it for this quick crash course. The solutions are here if you want spoilers. So basically what I have learned here is how basic React components work, some of the core principles of React. How do you go about adding navigation using the React router? That was a bit touch and go, but that's like pretty much the common pattern that you'd use. And then the last bit is like, how would you go about making GET and POST requests to an online API? Yeah, so the next steps will be like covering slightly more advanced topics, such as React hooks, React Redux. So React hooks would be one solution to the prop drilling problem that we saw earlier. React Redux is another way of thinking about how you manage state. And as you start developing more complicated projects, you might need to start using dev tools that improve the developer experience, and there's like way more. So the whole front-end view is actively developing, new things come out all the time, and it's always great to be in the loop. So plenty more to learn and plenty more to build. Yeah, cool. So with that, do start working on the assignment. And if any questions, just ask in the chat. Thanks. Okay, so Ryan is asking, what does it mean to wrap components around a route flag? So the general idea of routing is basically what gets rendered when a particular URL path is entered. So, so for example, this is the base path. So what gets rendered when the path is like this? What gets rendered when the path is like this? Oops, sorry, it's double slash. Yeah, so what gets, okay, my bad. Oops, sorry, what gets rendered when the path is like this? So that's the problem that routing is trying to solve, right? And for that to happen, we use the React router to solve that problem for us. And how that works is basically in the app component, which is like the base component, you declare what are called routes. Okay, so first off, you have the navigation bar that's on top, and that is not wrapped in a route object because one is it's always there, it always to be there, right? That's why it's called navigation bar. And if you actually look into navigation bar, it also has like routing properties as well. But that's for later. So what happens in the app component, right, is that it only contains the nav bar, which is always there, and the rest is actually empty. We do not add any additional components unless we want it to always be there, like the navigation bar or even a footer. So for each route, right, we define it using a React component. So it takes in a couple of properties. So the first one is the path. So that's the URL, and then its corresponding component that it would render. So you can think of these as like conditional rendering. So if the path is just a simple slash, we would render the questions component. If the path is slash question slash a particular number, you then render the question component, the one without the S. And then because of this particular syntax here, this question component would get this in its properties. And lastly, when the path is slash new question, we render the new question component. So hopefully that sort of makes more sense. Does that answer the question?
To add on a little to that, right? If you look at this slide that Raynold is on, at the bottom you can see that you are exporting this app component with a with router. So what the with router does is you can just accept that it magically tells the rest of the app how to deal with this these three route components that you have declared, like route, exact path slash, exact path question, question ID, new question, etc. So with this wrapping, okay, your question was, do you have to wrap every component? No, you don't have to wrap every component. You just have to wrap the ones that you want to declare a route for. So, but for your app to know about all these routes, you do have to wrap it with a router component, which is magically done with this with router function. So Raynold didn't have to write a router element that wraps the entire app. Yes, it will persist throughout, regardless of the path. Yeah, Raynold, maybe you can like demonstrate the add bar and then navigate around.
Okay, sure, thanks. Yeah, so the main reason why we didn't have to wrap, yeah, here. So like notice that these were wrapped in the route component, right? Because these are conditionally rendered based on the path. Whereas the navigation bar is always there, right? Because like that's why it's called navigation bar. So that itself is not wrapped in a route because we always want it to be rendered regardless of the path. But if you sort of look at the nav bar, right, it still contains sort of like code related to the router, primarily because it contains a link as well. So notice that when we click on the navigation bar, we want to go back to the route. So because of that, we need to sort of like inject this router code in as well, so that React router knows that, hey, when the user clicks on the navigation bar, I want to go back to the route, like this path. Like, does that answer your question? Yeah. So basically, the best way to think of routes is conditional routing. Yeah. So this is only rendered if the path is this. Yeah. So like as you can imagine, if you have paths that are the same, right, then like weird things start happening. Right?
So Ryan, your question is, if you want two components in one path, do you abstract it into a bigger component, right?
Yeah, that sounds about right. So basically, you just wrap it around either a div or like a parent component.
Yeah, that's one thing you can do. Earlier, Raynold mentioned that if you have like two paths that are the same, right, then weird things start happening, right? By weird things, what he means is that because both of them match, so the both of them will display. So you also can do that. And if you are designing it to be that way, you can go ahead and do that. Sometimes it's kind of weird. So usually people like to do what you are talking about, which is wrap both of them into one bigger component.
Yeah, hi. So like for those that are working on the homework assignment, I forgot to add this slide in, but basically you have two new endpoints here, which is the post upvote ID, which upvotes a question, and post downvote ID, which downvotes a question.
Just a question, yeah. So can you do an example where you like pull something from some other website's API and display it on your own, for example, localhost or your own website?
So the question is getting data from another website and displaying it here, right? So what kind of data? Like just text or like image? Pictures. I mean, usually, like if it's just an image, right? Like you won't even need React for that, right? Like it'll just be like an image tag, and then the source pointing to the URL address. And if it's text, it'll basically be like whatever we did in the Q&A app, right? So you need to know what the endpoint is. You make the call using the EX iOS library, and that happens in the component dip mount function. And then based on whatever data you get, you will then update the state.
Raynold, maybe you can demo a quick example with like a random user.me API. Yeah, which is very similar to your questions, but it should have images.
Okay, so I think it means that's right. Actually,
the request is at the bottom. There's an example for the.
Right. Okay. So suppose I want to generate a random image, right? So I'll just make the API call. So in this case, the URL is this, right? So you just make a GET request with this URL, and then we'll get in response this particular object, right? So if I wanted to just display an image, I'll just search for this particular URL and then sort of render an image element with the source pointed to this. Yeah, I know if you're developing more complicated React websites, you can start using this thing called React Developer Tools, only for Chrome. And it basically allows you to inspect the components. And it gives you like interesting stuff that you can't really do with the Chrome inspector, such as the properties, hooks if you're using those, and like the sort of things. So it makes it a lot easier to debug your React components and see like what's happening underneath the hood. Yeah, so definitely do consider using React developer tools. And so I guess like the plan for the rest of the workshop will be I'll just run through the solution at 2:35, and we'll just set aside the remaining amount of time for like questions if people may have. And of course, if you want to chat more about your project, do free to do so. So we'll start off with the given code here. So it's there are like minor changes from the original one. So for the hint, let's go to questions.js. So the first thing here is we need to edit this bit of code here. So to do that, we'll just change this with this dot upvote. All right, and then let's just handle the upvote case first, right? So we'll just make it call this internal method called upvote, and then we define upvote here. Right. So the first bit is we need to do a couple of things, right? So we need to call the API and update state, right? Okay, so let's just take a look at the hint here. So basically, like we're trying to do the exact same thing here, right? We are re-rendering the component after making a post request. And then if we scroll down to the solution, what they are basically telling us to do is we have this handler method. So it takes an E, which is the event. So the first bit is the E prevent default. So that's a bit of HTML magic there. And the whole point of that is basically to intercept the underlying link. All right, so notice that at least now when I click the upvote, nothing happens, right? But if I were to ignore it, if I were to uncomment it out, you'll encounter this bug or like behavior where we just go straight to the question, which is expected, right? Because if you see here, we are clicking on this button, which is wrapped around this link component. So what's going to happen here is that after we are done processing the button click event, this one gets fired, which in turn redirects us to this URL. So things that we don't want that to happen. So to do that, we basically say like, hey, stop passing this event up the parent tree. So with this bit here, the link is no longer exactly triggered. So that's the first part. So that would explain this line of code here. All right, so next bit is we need to make the API call. So in this case, it's a post call. So let's add that bit here. So basically, XML's post, and add in the host name. And then as mentioned previously, we want to hit upvote, right? So we're hitting this particular endpoint. So I want the question ID for this, right? So we check here what we have passed to us as props. We need the question, right? So the question comes from the props here. So to extract the ID, it will just be this .props.question.id. Perfect. So, and then, oops, okay. Yeah, so I'm following the structure here. So then, so after we make the post request, we'll then call this particular method here, where the parameter is the response, and then we set the state based on like what happened in the response. All right. So in this case, we do this. So this dot set state. So we need the previous state, and then we transform it like so. So votes is now the previous state votes plus one. And that should do. Let's check everything matches up. Oops. Yep. So I click on this. All right. So hold on. There we go. Okay, so this settles the upvote bit. So the another one is we need to set this one here. So this is pretty straightforward, right? This would just be this state and votes. All right, cool. See, so now they all now display the votes, and when I click the upvote, it gets updated. So if this doing the downvote should be fairly straightforward, right? So it'll just be copy pasta this, and it'll just be this and this. Oops. Yep. Then I need to change this to call this down. Okay, so upvote works. Downvote is working as expected, and we're done. It's like that, pretty straightforward. Cool. You guys have any questions? Yeah. So make emojis like so. Cool. And that is pretty much it for this workshop. If you have any questions, just feel free to just ask in the group. If not, have a great day, guys.
Okay, before that, I've posted a link into the chat to a GitHub repo called Awesome React. So this is like a community consolidated list of React-related stuff like tutorials, resources, libraries, frameworks, and a whole bunch of stuff. So you can check it out and see if there's anything that's relevant to your project and go from there. So it's pretty comprehensive. There's components for things like maps. There's libraries for state management. Sometimes I think there's too many of them, so you have to make a choice of what you want. But I guess choice is a kind of a good thing. Raynold, there's a question about sorting the cards by number of votes in descending order.
All right. Okay, so to sort, right, that would be, so there are a couple of ways, right? So either you add the sorting logic, so if you look at how the questions are rendered, it happens.
It's at the bottom, yeah. Line
so this is
114.
Yeah, so that's where it's rendered, right? So you can do a couple of things. Like you add the sort here, so you can do something like this. Oops. So you sort and then you add your logic here. So that's one possibility. An alternative is let me see. Actually, I can just do it here. So let me just quickly check. Okay, so basically I have a sort function here, and I just need to implement the comparator, right? So it'll be just Q1 and Q2, and I'll then compare it by Q2 votes minus Q1 votes. So this way, oops, I expected token. What's going on?
I think you can chain the sorting from line 116, right?
116.
Yeah, the dot sort, you can chain it from line 116.
So we can just do this.
Oh, that also works.
Yeah, so it's probably not the best code, but it sort of works. Yeah. So in this case, it's now sorted in descending order. There we go. Yeah, so I guess the downside to this is that doesn't really update it on the fly. So in this case, I have this card that's actually more upvotes than this, and it doesn't really sort, right? Because the sorting only happens on the dip mount, which only happens when you make a get call, which returns you the live vote count. So for this bit to like dynamically sort would require an extra bit of work. So the only way to get it sorted is to refresh the page. So I guess like if you have a bit more free time, you can think about like how to actually have this like live sorting feature. So like I guess as a quick like food for thought here, right, is that there's actually a couple of things kind of wrong with this approach. Oh, it's not here. Okay, so there's some limitations. So the first one is, So the first one is that when we first have the questions component, right, we first get the questions from the API, and then we pass each individual question as a prop to each question card, which then becomes its own state, right? So the state is then dependent on the votes property. So notice that when we do an upvote, right, we now have this like divergence in the state of the world, because for example, when I do this, right, so when I refresh the page, this particular card had 42 upvotes, right? And then this question card had a state where the votes is 42. But if I were to do this, it becomes 43, but then the state of the questions here still thinks that's 42. So we have this like weird divergence in state. So usually one way to get around this is to sort of like rethink how you store and pass data around, which is one of the key problems that Redux tries to solve. So in this case, if I wanted like the state of the world to be consistent, right, I must pass down handlers and say, hey, if the vote was updated, call this, so that the app gets updated, this sort of things, right, which gets like super weirdly if your project gets more complicated. So with that, there'll be like a decent segue into like additional React-based libraries like like Redux. So that's like some food for thought for this particular solution. Like it works, but it leaves us in a state where this card's view of the world is different from like the like parents' view of the world, and that could cause problems once you start working on more complicated projects. So the question is, if you use handlers, would it update live? It would work if we push the sort code down here. If you add handlers, what? Okay, so the first one is so the question is, if you use handlers, would it then update live? It would, if and only if you update the questions using a set state. So if the handlers call a set state, then I guess it would work, but the sorting function has to be done here. So you need to add sorting here, right? Because previously we only did sorting on component demand, right, which is actually only called once. So even if the state gets updated, the list is already sorted, it will not change position, so it will not auto-update by itself. So hopefully that answers that question. The next one is, if you want to limit the ability to upvote/downvote to one time per person. So in that case, what per person? So now we're talking about like per person basis, right? So that's a bit complicated because that would involve having to send additional data to the server so that the server knows that, hey, the same guy is posting multiple times, right? So assuming that we have that in place, so on top of like making a GET request, we also send the user ID. What we could then do is actually update the API. Update these two endpoints. So basically, it would return 200 if the upvote was successful. If the person is trying to spam, then would return a different number, like maybe like 4,000, for instance. And we can then modify this upvote code. Then, okay, so if you look at this, it takes the response, right? So basically, we just check the response object. If it returns us a code 200, we would then update the votes. If not, we just let it be. So this way, like the visuals like remains consistent with what is happening in the backend. Does that answer your question? Awesome.
Yeah, I think Xiang-En actually asked a very interesting question. So Raynold's solution, right, is Raynold solution will work. And on top of that, right, what you can do is you can have like visual cues for the user. So for example, when they've already upvoted something, you can you can consider like changing the style. Like for example, you make it like a lighter shade of red to show that they cannot press it again, or you kind of make the upvote button like a toggle, so that if they've selected upvote, it shows that it's toggled, and then they have to like press it again to untoggle it, instead of making it look like something that you can continuously press. So this goes more towards like design issues, and it's always good to consider about how you want the interface to look to your users, so that they can have expectations of how it's supposed to behave. Yeah, thanks for the question, Xiang.
So someone asked, not related to React, but what backend / technologies you recommend for beginners to learn? So I guess if you're already using ReactJS, you already know JavaScript. So a popular combination for backend would be Node.js, because like it's JavaScript, right? So you only have to learn one language. So I guess a recommended one would be Node.js plus Express. Like this is a very common combination. And I guess for yeah, that's pretty much for backend, right? So TLDR, Express plus Node.js, because it's still JS. And for databases, usually it's two main choices, right? It's either MySQL, if you want to interact with like an SQL-based database, or NoSQL if like you don't want to commit yourself to a particular data model. Yeah, in general, like unless you're looking for like super data-intensive applications, it's fine to start with MongoDB for that, because it's like pretty easy to pick up and learn.
So Wicked, if you can explain your project a little if you want, then maybe we can recommend something more specific depending on your project. But what Raynold said is pretty much like go-tos